Problem number 1, TwoSum. This problem likes to be asked a lot at Amazon. So today I want to go over this problem and its many different implementations and solutions to it. So starting off, given an array of integers nums and an integer target, return indices of the two numbers such that they add up to that target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So the order of the indices that you return does not matter in this case. Also, a clarifying question here could be that you're actually returning the indices and not the actual numbers themselves. So that is a big distinction to make here. So looking at some general solutions and trying to think out our thought process here, the first thing I would think of is a brute force solution, right? So what if we looped through every single number in the array, found the complement, and in this case, a complement is what the number needs to add up to the target number. Now, what do I mean by this? Looking at this example here, we have the target number of 9, right? And then our first num in that array would be 2. So the complement between 2 and 9 would be 7, because 2 plus 7 equals 9. So in this brute force solution that I was talking about earlier, we loop through all the nums, loop through, check again by looping through the rest and seeing if the complement is there. Okay, now this code does look kind of ugly, this pseudocode that I'm giving you here. But basically, in this brute force solution, there would be 2 inner for loops, which means the time complexity would be O of n squared, which is not good. That's bad. So to sort of fix our solution here, we need to think of a way to get our time complexity down to O of n. Now, what are some general thoughts that you might have when it comes to finding time complexity of O of n? Well, you got to think of data structures. What are some good data structures that you can use in this solution that will help you get your time complexity down? One of the best data structures to use in any of these types of questions is actually the hash map. If you haven't learned what the hash map is already, I would recommend that you do that ASAP, as this is used in many Leetcode problems and is used to get the best time efficiency. Why is that? It is because underneath the hood, the hash map gives you constant lookup time for any of its elements. So when you're looking up the elements, you do it in constant time, which is good in this case, which means we'll be able to get a time complexity of O of n. So let's sort of write out some quick pseudocode for how a hash map would be helpful in this solution. Well, to start, what if we had a hash map that contained all of the complements? So let's just call this the complement map in this example. Yeah, my brackets look terrible. Ignore that. So in this complement map, we basically iterate through the nums. So loop through nums. And first, calculate the complement. So let's say in this example, right? Let's take this array. Let's put it up here so we can see it in a better case here. So say we're on 2 here. If we calculate the complement, when we have the target of 9, that's the target we're looking for, it would say, okay, this is our complement. This is 7. So what do we want to do with this complement? We first want to check, is the complement being seen already? So first thing we want to do is check if complement has been seen already, and we'll put this in the code in a bit. has been seen already. Handwriting's terrible. Sorry about that. Then that means we've seen both the number and its complement that we need. So we can just return the correct indices. Okay? So we return the correct indices. If that's not the case, so outside of this if block, if that's not the case, we actually want to put the complement, sorry, not the complement. We want to put the number in the complement map. So basically, this complement map is going to store the number and its indice. So let's just say I was our index variable in this case. So with this sort of pseudocode, let's sort of walk through this solution real quick. Sorry, my handwriting is so bad right now. Okay. So say we have the general example 2, 7, 11, 15, and I'll use red here to sort of show out how our code works. So to start, we have our map, right? Our map doesn't have anything in it, okay? First iteration of the loop, we have 2. 2's complement is 7. Okay, so that's calculated. Is this 7 been seen in the map yet? No, because it's empty. Okay, so what we're going to do is we're going to put 2 and its indice, so 0, that's our index, into the map. Okay, so that's our first iteration. Now we're on our second iteration. Point at 7. 9 minus 7 equals 2, so it calculated our complement. Okay, now we go down here to this statement. Is this complement been seen already? We check our map. This is constant lookup time, right? That's the big difference with hash maps that make this so efficient. Constant lookup time. It sees, oh, okay, 2 has been seen already. So that means we have the number and the complement we need for this 2 sum. So that means we can go ahead and return. So it's going to return the current indice that's at, which is 7. And the indice of that is 1. And then it's going to return what it gets from the map, which is the 0 indice. So this is basically what it would return. This would be the answer / return value of this example. Now, one more thing to take note of is our answer had 1, 0 as the return value. This explanation is saying 0, 1, and you're like, oh no, it doesn't actually work, right? Well, if we look up here, it says in a clarifying sort of way that we can return our answer in any order. And that's very important because this solution would not work otherwise. Okay, so that is basically our pseudocode for this. Now let's go ahead and hop into Leetcode and get into some coding. Now, this coding approach that I'm going to give you with the hash map involved gives it a O of n time complexity. For space complexity, it's actually also going to be O of n because you need to fill the hash map with the different complements, okay? So let's go ahead and get into the code here. The first step is to take our complement map and initialize it, or declare in this case. Now, using the cool function enumerate, we can iterate through each index and value of the nums. This is a cool function in Python that basically lets you get the index and the value of a certain thing, okay? Now, our first step here is to calculate the complement. So the complement will be the target minus the value, okay? Once we calculate the complement, we want to check if the complement is in our complement map. Sorry, I need to do better at actually naming these. Let's go ahead and name complement just our complement map. Okay. So if we've seen our complement already, then that means we can just return it. Okay. So instead of returning the actual value here, we have to return the index. So the index is what will be returned, and then the index corresponding to the complement is what will also be returned. Okay. So this is our return value. And then finally, if that's not the case, if we haven't seen the complement yet, then we want to store not the complement, but the actual number in the complement map, right? So we'll store the value with its index. Using this code, we can efficiently solve the two-sum problem. So go ahead and looking at our solution here, we get a runtime of 61 milliseconds. It beats 63% of users with Python 3. Oh my, I don't know what's wrong with that chart there, but this solution works great, has a great time complexity and space complexity. Now, if you want to learn more about this difficult problem, go ahead and click here to learn more and continue that Leetcode grind. Thank you so much for watching this video.